International Space Elevator.
The most difficult and most expensive part of going into space has always been the first leg of the journey. The first few hundred kilometers are where the pull of gravity is strongest, and up to now, the only way to overcome this obstacle has been to use costly, inefficient, and dangerous rockets.
Now, an alternative route to space, long a part of popular and science-fictional imagination, is becoming an emerging technology due to advances in science and engineering, the space elevator. In 1895, Russian scientist Konstantin Tsiolkovsky was inspired by the Eiffel Tower to propose a tower that would reach into geostationary Earth orbit. Another Russian engineer, Yuri Artsudinov, made a more feasible proposal in 1960 with the classification of the space elevator as a tension structure. Since then, work by American scientists Jerome Pearson and Bradley Edwards, the discovery of carbon nanotubes by Japanese physicist Sumio Iijima, and Arthur C. Clarke's introduction of the concept into popular culture have solidified the foundation for this emerging technology. The basic design includes a base station on Earth, a counterweight in space, and a cable holding the whole structure together, and climbers that would move passengers and other cargo between Earth and space. The cable and climber components include two kinds of emerging technology: wireless energy transfer or power beaming to power the climbers.
The idea is you use a laser to transmit electrical power through the air, without wires, to a device at the other end that uses that power. The way it relates to the space elevator is the idea that you wouldn't pull a cable up and down like a rig, you might do in a pulley on an elevator, because then you'd be moving twice the weight of the cable. So the idea is it would be self-propelled and it would just climb the cable.
And tether technology for the cable.
The concept in that project is the electrodynamic tether, which is a tether, a cable that can conduct electricity. So therefore, as it moves through the magnetic field of the Earth, as it orbits the Earth, it can use that force that is generated electrically as a force to move the whole collective spacecraft around. So it can maneuver without using propellant, which means it can go on almost indefinitely without being refueled.
The main advantage of a space elevator is cost. Whereas a typical shuttle launch costs $20,000 per kilogram of cargo, a space elevator can carry the same amount of cargo for only $200 per kilogram.
Moreover, the building cost for the infrastructure of a first space elevator is estimated around $6 billion US, which is a little bit less than the cost of the cheapest available rockets nowadays.
Another benefit to consider is environmental impact. Rockets put a lot of pollutants into the atmosphere. A single shuttle launch can dump 75 tons of chlorine into the fragile ozone layer. A space elevator, on the other hand, generates its lifting power on the ground using clean fission or fusion reactors.
What is the goal of the space elevator, and what would it be used for?
The goal is, to replace the normal way of taking using rockets to take things up and down, with this elevator that would take up, first of all, people, and then food and things. The return would not be the fiery, dramatic reentry that you normally have, but you just ride back down again like you went up. And then everything else we need, materials and equipment, which would not have to be now designed to withstand the forces of acceleration and a rocket launch. You just take ordinary things and put them in there and take them up, and take them off when you get at the probably somewhere along the way before you got to the counterweight, you would get off. And what might end up happening, and you can imagine at this future point, perhaps a lot of what we'd be using it for is to bring things down. Resources that we were getting from asteroids or from the moon being brought back to be used on Earth.
Right now, the space elevator still faces engineering issues, mostly around the cable's material. Until the recent discovery of carbon nanotubes, no material existed that was strong enough to withstand the Earth's gravity. However, the scale needed for a space elevator is far beyond current carbon nanotube technology.
The idea with carbon nanotubes provide a material that shows promise of being strong enough and light enough to do this job of supporting its own weight plus the weight of another object over a length of hundreds and thousands of miles. Once you've developed that past the laboratory state we're in now, where you only have a few millimeter lengths the ability to build things like that will affect every industry and revolutionize every industry, because we'll be able to make structures that are incredibly lightweight and strong, and that certainly will revolutionize our world in a lot of ways.
Two other important questions to consider are the location of the base.
You want to be on the equator in order to take advantage of the position in orbit above that. So you look at the globe, and there's a lot of water, and in the ocean might be the most reasonable place to do it, because you probably want to be in a place that's somewhat remote in case things go wrong. So a platform in the ocean seems like a good idea. You could be out kind of in international water, and I don't know if you may want to have some ability to move the base around a little bit and have some flexibility so you can absorb changes.
And the financing and ownership of the space elevator.
Just because you can build it doesn't mean you have a right to tell everybody else to stay out of your way and decide what it costs to move things up and down, independent of everybody else's interest in it. So it is, I think, a complicated thing, though it would be an enormous project. It would take a lot of capital to put it in place. And whoever does pay for it will have a lot of influence over its operation, but they can't, again, operate without the cooperation of other people. So.
Once these engineering and political problems are solved, what other future can we envision due to the space elevator?
It could almost sort of turn the whole thing upside down, where most of the traffic might be coming the other way. If we're now using space as a place to get resources instead of from the Earth, and using space as the real base for our industrial activity, and moving that off the Earth, which perhaps was never meant to support the kind of things we do, burning things, and you can do a lot of those kinds of things in a space environment without really impacting any biological kind of environments like we have on Earth. So it's a different world, and almost one turned upside down in a sense. That's kind of the vision of the science fiction writers like Arthur Clarke, and of the Earth being a garden, and all the industrial activity happening beyond the Earth. So, and it's hard to imagine that happening just with the kinds of rockets we use today, but that's not what we'll be using forever.
A single space project in this period will be more impressive to mankind or more important for the long-range exploration of space.
International Space